Okay, this is going to be a lesson on Student Learning Task 5, which is really a good continuation of Student Learning Task 4. We're going to continue working with z-scores and the normal distribution table to find some probabilities of situations that are normally distributed. As a warm-up, what I would like you to do is please turn to page 41 in your packet and calculate the z-scores for these 6 situations. You can just put the z-scores right where it says explanation and then go ahead and rank them. Pause the video while you take care of this task. All right, so I'm gonna write out the first 2 and then we'll just go through the answers. If I have 1,243 Fruit Loops and the average is 800 Fruit Loops, and I divide that by a standard deviation, they're Tutti Frutti-Os, excuse me, they sound like generic Fruit Loops to me, and I divide that by 120, I will get a z-value of 3.69. So that one is quite unusual, very high above the mean. For number 2, your cat weighs 6 pounds. The average cat weighs 10 pounds, which maybe means you need to reconsider your cat's name, with a standard deviation of 2.1. Gives you a z-value of -1.9. I'm going to set up one more for you. So the battery died after 20 hours, so z equals 20 minus 40 over 1.2 gives you -16.6. I think that's going to be really hard to beat that. Oops, sorry about that. And then the last 3, you should have gotten z-values of 1.74. For the earthworms, you should have a z-value of 3.96. And then for letter F, the z-value is -1.4. So the question is, which one is the most unusual of these 6? So I would have to say that probably letter C is the most unusual. It is definitely the furthest from the mean. And again, we're not really looking positive and negative values. So for example, now the earthworms, they're gonna beat out the Fruit Loops because even though, well wait, they're both positive. So earthworms beats the Fruit Loops, so then the earthworms, then the Fruit Loops is 3. And then for number 4, we're gonna go with this one, the -1.9. Again, we're almost looking for like the absolute value to see how far they are from the mean, which one's the furthest. So that'll be number 4. And then we have these 2, so then 1.7 beats -1.4, that's 5. And then this is number 6. Okay, so last night you had homework on z-scores, and hopefully you checked all your homework on Drive and everything matched up beautifully. And if not, you can find myself, or if I'm still not here, you can find Mr. Davis or Miss Weiss, and they are happy to entertain any of your normal distribution curve questions until I get back. Today's lesson is a really good continuation, like I said before, on SLT 4. SLT 5, we're just going to be using z-scores and our tables again. We'll use a combination of the tables and the calculator so you can get more comfortable with that. So go ahead and turn to page 43 and read the situation. Should we send out a certificate? Just read it. Okay, so for this situation, we're going to change the number slightly. I would like you to please change the 7 point whatever that was to just 7 and just make this 11. So what we are trying to do now, this is a lot like last night's homework, we are given x values. We are going to turn them into z values, and then we're going to go use the table and turn them into percentages. Make a little note of this process. We're going to go from x value to z value and then find a percent. So let's go ahead and find the z values for 7 and 11. So 7, the z value will equal 7 minus 9.44 over 1.75 And that's going to give us a z-value of negative 1.39. And then the other z-value for 11. Gives us 0.89. Okay, so we've gone from x value to z value. So our next step is to go from z value to percent. Before we do that, I'm going to draw a little picture so I get a better idea of what I'm looking for. You always should draw a picture. I don't care if you hate it, suck it up. And I've got 0 in the middle. So let's put 0.89 over here, and we'll put negative 1 point, and where's my handy pink pen? We are looking for the percentage of data between those two. So the first thing I'm going to do is I'm going to go on my table and I'm going to look up the number for 0.89. So I'm going to grab my tables. Here it is, 0.89. So this is my positive table because I have a positive z-value. And I'm going to go 0.8 and all the way across to 9. And I've got 31.33%. I'm just going to put it in. I'm going to keep it a decimal. Okay. So now I want to subtract off this white area to the left of negative 1.39. So I'm going to grab my table for the negative values. Mine just happens to be blue because that's what color I had in my printer. Negative 1.3 is over here. And then I'm going to go all the way across, and I have 0.0823 for negative 1.39. So from here across, 0.0823. Double check that. Yep. Okay, so all I'm going to do is I'm going to subtract off on my calculator 8133 minus 0.0823, and that will give me the area in the middle. I'm just going to let you know, I just heard the garage door go up, so there's probably going to be children interrupting this video momentarily. So we get 0.731, or you can write that as 73.1% of the people had a score between 7 and 11. So just to show you, if I wanted to do this on my calculator, I could totally do this. I could go second VARS, pick normal CDF. My minimum is 7. My maximum is 11. My average is 9.44. My standard deviation is 1.75. And again, I did get something very close. I'm only off by 0.1%. Okay, and I want to remind you that for this problem, we went from x to z to percent. Go ahead and read letter B. Okay, for letter B, we're going to be going from percent to z to x. So Fred wants to know if his score is in the top 2.5%. So the question we're really trying to answer here is, what score does Fred need to get to be in the top 2.5%? So let's draw a picture. Let's go. So the top 2.5% is going to be here. We know that this is 2.5%. The question is, what is this z value and what is this x value here? So to do this, we are going to look in the center of the table. Okay, we're looking for in the center of the table, and we're not looking for 2.8, because remember, the table only gives us values to the left. So to the left would be 97.5%. And we're going to just look for which one everyone is closest. We're not going to worry about averaging. So for 97.5%. So that we want to remember that that's a positive z value. So we're going to grab our positive z value table. And we're looking for, it's like a little needle in a haystack thing. 97.75. Oh, there it is. Came out perfectly. Woohoo! It doesn't normally happen that way, so that's exciting. So that's 1.96 without a doubt. 1.96. So we've now solved part of the mystery that the corresponding z value is 1.96. Okay, so now what we're going to do is we're going to say z equals x minus average divided by standard deviation. Okay, and we're going to solve this equation. So go ahead and multiply both sides by 1.75. And we get 3.43 equals x minus 9.44. Add 9.44 to both sides. And we get an x value of 12.87. So the question is, does Fred get a certificate? Congratulations, Fred. You have qualified for a certificate. Fred makes the cutoff. I have run out of space. So I want to investigate this a little bit further because really we have just hit the tip of the iceberg on this. So let's say I wanted to check this with my calculator to see how to find an inverse. So if I'm trying to go from percent to z to an x value by calculator, what I'm going to do is I'm going to go to second distribution and I'm going to pick inverse normal. And the command I'm going to do is area, whoop, I just added a D on area. I don't know what that was all about. Area to the left, comma, the mean, comma, the standard deviation. Okay, so on my calculator, if I wanted to do this problem again, I could go second vars, inverse normal, the area to the left. And I still need to really make that picture because if I try to put in the 2.5, it's going to give me a negative z value and I'm going to be wrong and sad. So you need to really make sure you make the picture and you understand conceptually what the area to the left of your z value is. So that's going to be point, and again, it's got to go in as a decimal, comma, with a mean of 9.44 and a standard deviation of 1.75. And there is our 12 point, look, that was like perfect. We had 12.87. It was 12.87 on the calculator. Yay, us! So just to put this in, we did it on the calculator by doing inverse normal. We did 0.975. The mean was 9.44. 1.75 gave us an x value also of 12.87. Good job, guys. So just as to give you another situation, let's pretend that if the top 2.5% got a certificate, let's say that the top 10% get a gold star. Get a gold star sticker. I don't know. So go ahead and draw the picture and determine the percentage we're really dealing with. Okay, hopefully what you did is you drew a little normal curve. Oh, that's super ugly. Whatever. So here is our top 10%. And what we're really looking for is this 90%. This 90% corresponds to what? So if I grab my table and I'm looking for exactly 0.9, I don't think I see exact, oh, I got close. You know, I'm gonna go with this one. If I'm looking here for 0.9, I have I have 9015 and I have 8997. This one's closer. This is the one I'm gonna use. So it's 1.28. So I'm gonna go so that was my z value, 1.28. equals x minus average over standard deviation. And I'm gonna, on my calculator, it's a terrible looking 8, 1.28 times 1.75, and then add, just like I did before, I'm solving this equation. And so I find out that x needs to, you need to have a score of 11.68 to get the runner-up sticker. Okay, again, we went from percent, we had our percent, then we found our z value, and then we found our x value. If I wanted to do this on my calculator, I would do second vars, inverse normal, 90%, 9.44 is the average, 1.75 is the standard deviation, and I would get, shockingly, the exact same thing as I got from the formula. That's the minimum score to get a sticker. So the next page asks you to write like a letter to Fred, I think. Let me see. All right, so imagine we want to, I mean, yes, Fred, yes. Fred gets a certificate. And obviously we have all this lovely work that supports Fred's certificate. So your homework tonight is pages 47 to 49. You are more than welcome to use either normal CDF or tables. All that I ask is the following. You make a picture for every single problem. So I'm gonna model one of each. I'm gonna model one with the normal, with the tables, and I'll do one with you using the calculator. But I really need you to make a picture so that I know that you have a conceptual understanding of the problem. So take a minute, read page 45, and then we'll do the first two parts together. All right, so here's my curve. I have an average of, wait, this is males. For food is 261.5. All right, so less than 280. 280 is going to be up here. And I'm looking for this amount. So I'm going to go 280 minus 261.5 over 16.25. I'm going to grab my calculator. And I have a z value of 1.14. So like this is a situation where I'm given an x value, I turn it into a z value, and then I'm gonna go percentage. So x to z to percent. So I'm gonna look up on my table 1.14. Here's 1.1. And I have 87.29. So the probability that x is less than 280 is, I just forgot what the number was, 87.29. You don't need to write it this way, but I'm gonna start writing it this way. So now more than 270, again, this is still gonna be a positive z value. So here's the average, and now here's 270, which is above the mean, and I want more than, so this is really the area I'm looking for. And I need to remember that my table only gives me values to the left. So even though this is my x, I'm gonna go find my z. Whatever number I get from the table is gonna be the complement of what I really need. So my z value is 52. So I'm gonna go on my table and I'm gonna look up a z value of 52. And I get 69.85. So I know that this amount here is 0.6985. So if I want the probability of bigger than 270, I need to do 1 minus 6985. So there we go. And just to show you on the calculator, if I wanted to do this with the calculator, I could do the first one by doing norm. Can you see that pen? Yeah, you can. Normal CDF. With the minimum value, I might want to pick 0 to 280, 261.5, 16.25, and let's just see what that gives us. 0, comma, yep, and it's really similar because I had 87.29 and now I have 87.25. Pretty close. And now for this one, I'm gonna do normal CDF. My minimum value for this one was 270, and we'll put a maximum of like 1,000. Average is 261.5. Standard deviation 1625. Bars 2. 1,000. And standard deviation. Okay, so that gives us 30%, which was, again, really close because we had 30.15. So the fact that it's 3, I mean, they're very, very close. Only 10% off, really, or less. Okay, so your homework is to complete pages 45 to 47. I'll slide up and let you see the answers so you can check without having to really go off the video. Here's the rest of the homework pages, and here are the answers.